Okay, hi everyone. In this video, I am going to do some more problems on signals and system. I have solved a lot of problems on signals and systems in the previous video also. If you haven't watched it, please go and watch it. And also there are a lot of problems on gate ECE in my channel. Please have a look at it also. And the PDF of this, all these problems will be available in my Telegram group, the link to which will be down in the description box, and also the link to my Instagram account and as well as a Facebook page and a Facebook group where I share study notes and also updates are also given down in the description box. So with that being said, I am going to start this video. First question is, consider a signal x of t shown in the figure. If the value of its Fourier transform at a frequency omega is equal to omega dash radians per second be x of j omega, then j omega dash x of j omega dash is. Okay, so that is what the question is asked here. Okay, so the thing is that x of t shown in the figure is this is our x of t. The Fourier transform at a frequency omega is equal to omega radians per second is x of j omega dash. Okay, that is when x of t have a Fourier transform of x of j omega. But when omega is equal to omega dash, x of j omega equal to x of j omega dash. Okay, and we have to find out what is x of j omega dash, x of j omega. Okay, so instead of that, we will first solve for x of j omega only, not for x of j omega dash. Okay, first of all, I am going to find out j omega, x of j omega. So when does this kind of output get in the Fourier transform? We have to use the property of Fourier transform. Okay, so one property of a Fourier transform is that d by dt of x of t will give a Fourier transform. If x of t is having a Fourier transform of x of j omega, then d by dt of x of t, and if it is taken, if this particular signal, so that is d by dt of x of t's Fourier transform will be like this, j omega into d by dt of x of t. Okay, so this is one important formula for Fourier transform. So we are going to, j omega x of j omega. Okay, so this is the property. So as you can see in the question, it is asked j omega x of j omega. So the inverse will be d by dt of x of t only, right? Because x of d by dt of x of t gives the Fourier transform j omega x of j omega. So j omega x of j omega will give the inverse of Fourier transform d by dt of x of t. Okay, so this is what we should know. Okay, and now we have to find out x of j omega. What is x of j omega? To find out the Fourier transform of a particular signal, the formula is integral minus infinity to infinity x of t e raised to minus j omega t dt. So likewise, we are going to do that in x of t. That is integral 0 to 1. 0 to 1, it is 4, right? X of t is 4 e raised to minus j omega t dt, plus again from 1 to 2, it is 2. X of t is 2 e raised to minus j omega t dt. Now we will integrate it. So I'll take 4 outside. We will get e raised to minus j omega t divided by minus j omega 0 to 1 plus, I'll take 2 outside. We will get e raised to minus j omega t divided by minus j omega 1 to 2. Okay. So taking minus j omega outside and applying the limits, we get e raised to minus j omega minus 1 plus 2 into e raised to 2j omega minus e raised to minus j omega. Okay. So I'll take 1 by j omega outside and I'm opening this bracket. Okay, we'll get 4 into e raised to minus j omega. Four into e raised to minus j omega minus 4 plus 2 into e raised to minus 2j omega minus 2 into e raised to minus j omega. Okay, simplifying, we will get 4 into 1 minus e raised to minus j omega. I am writing it once again. 2 divided by j omega into e raised to minus 2j omega minus e raised to minus j omega. Okay. So we will get, I am taking j omega outside and multiplying 4 and 2 inside. 4 minus 4 e raised to minus j omega minus 2 into e raised to minus 2j omega plus 2 into e raised to minus j omega. Okay, we will get 1 divided by j omega, 4 minus, this will give 2 into e raised to minus j omega minus 2 into e raised to minus 2j omega. Okay, so whole divided by j omega. Okay, and also in the question it is given that is omega dash is equal to pi. Okay, I forgot to write it. This omega dash is equal to pi. So we are taking it, that is at omega dash is equal to, this is x of j omega, and in the question it is given that when omega is equal to omega pi, it becomes x of j omega. So x of j dash is equal to, instead of omega dash we are going to write pi. So 4 minus 2 into e raised to minus j pi minus 2 into e raised to minus j, this is 2, right, 2j pi, the whole divided by j pi. Okay, we will get 4 minus 2 into e raised to minus j pi is cos pi minus j sin pi minus 1. Okay, minus 2 into e raised to minus 2j pi, also we get minus, sorry, plus 1, the whole divided by j pi. So 4 minus 2 minus plus 2 minus 2 whole divided by j pi, we get 4 divided by j pi. And again this is x of j omega dash. So in the question we have to find out the j omega dash into x of j omega dash, right, which is equal to j pi into 4 divided by j pi, that is equal to 4. So 4 is the answer. Okay, now let's do the next question. The signal x of t is depicted in the figure below. The trapezoidal pulse x of t is applied to a differentiator delayed by y of t is equal to d of x of t divided by dt. What will be the total energy of y of t? So we have to find out what will be the total energy of a y of t. So y of t is d by dt of x of t. So we will find out the waveform for y of t. Okay, so this is the waveform for x of t. From minus 5 to minus 4, it is a ramp signal. After that, it is a constant, and again it is a decreasing slope. Okay, so we'll write the equation for each interval. So x of t equal to . from minus 5 less than or equal to t less than or equal to minus 4, it is y minus y1. y1 is 0 here, equal to m. The slope here is 1 only. 1 into x is t minus x1. x1 is minus 5. So it will be plus 5. So t plus 5. And again from minus 4 to 4, it is 1. Okay. And from 4 to 5, what will be x of y minus y1. y1 here is 1, equal to m is negative slope minus 1 into x minus x1, that is 4. That is equal to x of t equal to minus t plus 4 plus 1, that is minus t plus 5. Okay. So this is it. So we have to find out d by dt of x of t, which is our y of t. So that is equal to 5 for minus 5 less than or equal to t less than or equal to minus 4, and again equal to 0 here for minus 4 less than or equal to t less than or equal to 4, and again this is 1, right? Okay, minus 1 for t is 5. Okay, so y of t have the equation like this. Okay, 1 0 minus 1 at specific intervals of time, and now we'll find out its energy. So to find out the energy of a signal, what is the formula to find out the energy of a signal? Energy of a y of t is equal to integral minus infinity to infinity y of t the whole square dt, modulus of y of t the whole square dt. So y of t will be equal to integral minus 5 to minus 4. What is it? 1, right? 1 square dt plus again minus 4 to 4, it is 0 square dt plus integral 4 to 5, it is minus 5 the modulus the whole square dt. So which will be, we get 1 plus 1. Okay, answer will be 2 joule. Okay. Now let's do the next question. Consider the following integral. I is equal to integral minus infinity to infinity t square plus 2t plus 4 del of minus 3t minus 9 dt. The value of I is. Okay. So I is equal to integral minus infinity to infinity. I am going to open this bracket. Before that, I'll use their form what property of a impulse signal, that is del of a of t is equal to 1 by a del of t. Okay, here it is, and also del of minus 3t minus 9 will be 1 divided by minus 3, modulus of a minus 3 del of t minus 9 by 3. Okay, 9 by minus 3. Okay, so I can write 1 by 3 del of t plus 3. Okay, now t square plus 2t plus 4. Instead of this, I am writing 1 by 3 del of t plus 3. So then I am going to open the bracket. We get t square into del of t plus 3 plus 2 into integral minus infinity to infinity t into del of t plus 3 plus integral minus infinity to infinity 4 del of t plus 3. Okay. So by the property of what impulse response, that is x of t, the integral minus infinity to infinity x of t del of t minus t0 equal to x of t0. Okay, so this is a property of impulse signal. That means 1 by 3. Instead of this, I can write x of t. X of t here is t square. So instead of t square, instead of t square, we have to replace it with 3. That is 3 square plus 2 into, again, x of t here is t. So the answer will be x of t0. That means instead of t, we have to take 3. Okay, plus integral infinity to minus infinity to integral minus infinity to infinity del of t is equal to 1. Similarly, integral minus infinity to infinity del of t plus 3 will be also equal to 1. Okay. Okay, here t0 is equal to minus 3. Okay, minus 3. Okay, minus 6 plus 4. The answer is 7 divided by 3. Okay. Now let's do the next question. Let y of t. Okay, this is the next question. Let y of t is the output of a half-wave rectifier circuit when an input x of t is equal to e sine omega 0 t is applied to it. For odd values of n, the exponential Fourier series coefficient of a y of t is. So y of t is the output of a half-wave rectifier. In a half-wave rectifier, we will get output only for one half of the cycle, right? Half of the cycle. So that is how it works. That means t0. We know that omega 0 is equal to 2 pi by t0. And if we take t, we will get 2 pi by omega 0. And this will be working for t0 by 2. Okay, half of the period. Okay, so I can write e sine omega 0 t is coming for half of the period. What will be half of the period? Pi divided by omega 0. Okay, so here also omega divided by, so pi divided by omega 0 till 2 pi by omega 0, that is the actual period, will be equal to 0. Okay, so that is it. Now Cn. Cn, that is a Fourier's exponential Fourier series. The formula is 1 divided by t integral minus infinity to integral over t x of t e raised to minus j n omega 0 t dt. So here we get 1 divided by, instead of t we have 2 pi by omega 0, right? That is omega 0 divided by 2 pi. We will get the reciprocal because it is 1 by t. And from 0 to pi by omega 0, I am taking 0 to pi by omega 0 because after that it is 0. Okay. So omega 0 e raised to minus j n omega 0 t dt. Okay. Instead of x of t, we have to write e sine omega 0 t. Okay, and now we have to find out the integration of this particular thing. That is omega 0 divided by 2 pi integral 0 to pi by 0 e raised to minus j n omega 0 t sine omega 0 t dt. I am taking e outside. Okay. So instead of a sine omega 0 t, I am going to write it as e raised to j omega 0 t minus e raised to minus j omega 0 t divided by 2j. Okay, we will get e omega 0 divided by 2 pi integral 0 to pi by omega 0 e raised to minus j n omega 0 t into e raised to j omega 0 t minus e raised to minus j omega 0 t divided by 2j. Okay, taking 2j outside, we'll get e omega 0 divided by 2 pi into 2j. I am taking this inside and this inside. Okay, we'll get e raised to j omega 0 is common here, omega 0 t is common here, right? That means 1 minus n, right? I'll write t here, minus e raised to minus j omega 0 n plus 1 t into dt, integral 0 to pi by omega 0. Okay, so we'll get e omega 0 divided by 4 pi j e raised to integral 0 to pi by omega 0 e raised to minus j omega 0 n minus 1 t. Here previously I wrote it as 1 minus n and now I took minus outside, so it will be n minus 1. Okay, dt again integral 0 to pi by omega 0 e raised to minus j omega 0 n plus 1 t into dt. Okay, and now I will integrate. I'll take j omega 0 outside. J square is minus 1 and with this minus it will become plus. Okay, omega 0 cancel out and we will get minus j n minus 1 pi minus 1 divided by n minus 1 minus e raised to minus j omega 0 cancel n plus 1 minus 1 divided by n plus 1. Okay, and now in the question it was asked what is the odd values of n, the exponential, what is the exponential? So for odd values of n, we'll see for n is equal to 1, what happens? C1 equal to e omega 0 e divided by 4 pi, right? E divided by 4 pi. This will be 1 minus 1 divided by 1 minus 1. This will be equal to 0. Here also it will be equal to okay. Here also it will be equal to 0. N is equal to 1, C1 is equal to 0 and n is equal to 3 also it will be equal to 0. N is equal to 5 also it will be equal to 0. So I can generalize it as Cn when n is equal to, n is an odd number equal to